Now we'll show you how to perform the analysis of lead in tap water using the anodic stripping voltammetry on Amel4330 in order to understand the analytical procedure. This is the sample of tap water. Add 20 milliliters of sample in the cell. Insert the magnetic rod. Add 2 milliliters of supporting electrolyte. Rinse the electrodes with distilled water, avoiding directly hitting the mercury drop. Dry the electrodes with soft paper, avoiding scratching them. Insert the cell onto the stand, while first pushing downwards the stirrer and after releasing it. Then open the main nitrogen valve and then set the pressure reducer. Now open the VA Peak software by clicking on the proper icon. First set the instrumental parameter. Select the electrode type, for our example, the dropping mercury electrode HDME. Select the analytical technique, in this case the differential pulse stripping voltammetry, DPS. Then set the parameter of the first step of the analysis, the nitrogen purge. Set the stirring speed, for example 300 RPM, and the running time of the purging, for example 5 minutes. Then tick off the activation of this operation. Set the parameters of the deposition. Stirring speed 300 RPM, deposition potential -800 millivolts, and deposition time 60 seconds. Finally, set the parameters of the scanning. Start potential -800 millivolts, end potential -200 millivolts. The range current can be set in a range from a minimum to a maximum value, or as an alternative, an auto-ranging control of the current can be chosen. The pulse parameters are preset on the most used values: 50 millivolts for pulse amplitude, 100 milliseconds for length, 40 milliseconds for sampling time. Anyway, the user can easily change these values. Set the scanning speed, 5 millivolts per second. If a solid electrode is used, it is necessary to set an electronic cleaning by setting a specific potential. For example, 100 millivolts and the length of this step, 10 seconds. This step is not necessary when using the dropping mercury electrode. Click on Exit at the end of the setting of instrumental parameters. Now set the analytical parameters by clicking on the proper icon. First select the analyte, lead. Automatically the peak potential will appear in the right side. This value can be changed by the operator. In this window, choose the analytical parameter to be used for the quantitative calculation between the height or the area peak. Select on the right side the concentration units of the results, micrograms per litre. In the downside window, choose how to draw the baseline between linear mode and SP-line, curve mode. In the upper right side, set the volume of the sample, 20 milliliters. the volume of the supporting electrolyte, 2 milliliters, and the volume of the additions, 100 microliters. On the right side, set the concentration of the lead standard solution, 10 milligrams per litre. Choose in this position the mode of the analysis, manual. The automatic option has to be selected when an automatic burette is used for the standard additions. Tick off the standard addition method of analysis. Then set the purging time of the nitrogen after a new addition and before the starting of the running, 10 seconds. Finally, click on Exit. Click on Start and confirm the starting of a new analysis. First, the purging with nitrogen, that is, the removal of oxygen from the solution. On the yellow bar, compare the actual step of the procedure, the purging at the moment. After the purging, 3 drops of mercury are discharged and the deposition of lead onto the drop take place. Immediately after the deposition, the scanning of the potential starts, just like the recording of the current. On the graph, the curve will appear. After the scanning, a tick will appear on the first cycle of the zero addition. Then the software shows the peak, the baseline and the height of the peak. In the upper window, the value of the height will appear. Click on Continue and the analysis goes on making the other cycles and the other standard additions. Second cycle, second height value. Click on Continue to start the third cycle. After the end of the zero addition, make the first addition of 100 microliters of lead standard solution by inserting the micropipette in the proper hole. Click on Continue and make the 3 cycles and the following 2 additions. At the end of every scanning, the final graph will appear in this form. The height values are reported in the upper window in this column. For every set of values, the meaning and the standard deviation is calculated and reported. Since the first cycles of the second addition is an outlier, this value has to be discharged by clicking on the respective tick. When each height value is checked, click on the regression line icon. The plot of the regression line will appear just like the value of the concentration of the sample, 105 milligrams per litre, and the data of the regression too.